In this edition, we look at this simple problem which asks us to find the domain of definition of this function fx, which is integral 0 to 1 dz divided by square root of x square plus z square. Now, the main thing here is that the function is defined as an integral, and the integral is over this variable z, and the function is of x. So we have to figure out at what points is this function defined. Now for that, we first look at the point x is equal to 0. Now if x is equal to 0, then integral 0 to 1 dz by root over z square, that is equal to integral 0 to 1 dz by z, and we know that 1 by z is not defined at z is equal to 0. So the way we try to evaluate this is that we try to take the limit as a goes to 0 plus of integral a to 1 dz by z. Now integral a to 1 dz by z, that is by the fundamental theorem of calculus, becomes log of z evaluated at a and 1, and therefore this is the limit a goes to 0 plus log 1 minus log a, and that is nothing but limit a goes to 0 plus minus log a. However, if you recall the graph of the logarithmic function y is equal to log of a, so here is a. So as a goes to 0 plus, log a goes to minus infinity, so this limit does not exist finitely. So f of 0 is not defined. So at x is equal to 0, the function is not defined. What happens at other points? When x not equal to 0, then integral 0 to 1 dz by root over x square plus z square, we have to evaluate this. Now this integral is a standard integral. From a table of integrals, we can find that this is equal to sine h inverse z by x, and when we put the relevant values, this becomes sine h inverse 1 by x minus sine h inverse 0. Now both of these quantities are well defined. Recall that sine h u is e power u minus e power minus u by 2, and sine h u takes all values between minus infinity to plus infinity. As u varies between minus infinity to plus infinity, sine h u also varies between minus infinity to. So sine h u is a 1-1 function and it has an inverse. So sine h inverse t is well defined for every t belongs to R, and therefore both of these quantities, sine h inverse 1 by x and sine h inverse 0, are well defined. So the integral 0 to 1 dz by root over x square plus z square is well defined for every x not equal to 0. Hence, the domain of definition of fx is R minus. Thank you.